Today we are going to discuss composite functions, chapter number 1. In that exercise number 1.1 we already discussed. Now in this session we are going to discuss inverse of an element, inverse of a function, method to find inverse of any function, domain and range of inverse function, properties of inverse function. Let's move on to the part 1, inverse of an element. Before going to our class, always we should start with let's close our eyes. God kindly provide your knowledge and wisdom to solve our mathematics problems and our daily life problems. Thank you, God. Okay, let's move on to the inverse of an element. Now we are going to discuss inverse of an element. So which I was written on the board, this was a complete definition of inverse of an element. Now you just observe on the board and we'll discuss it is in detail. Actually in earlier class what we discussed, that only was written. Right. So like f maps a to b is a function as we have discussed in earlier. If small a belongs to capital A is associated to small b belongs to capital B under the function f, then B is called the f image of A. So we write it as B is equal to f of A. We also say that this A is the pre-image of B or inverse image of B under function f, and we write it as A is equal to f inverse of B. So this is about the complete definition of inverse of an element. And let's discuss our with a diagram. So here this A1, A2, A3, A4, A5, A6, A7 is belongs to capital A, and B1, B2, B3, B4, B5, B6 are belongs to the capital B. So under a function f, so here f maps A to B. So now we discuss. Alright, here A1 is equal to, so what we can write it as f inverse of B3. Now A2 is equal to f inverse of B1, A3 is equal to f inverse of B4, A4 is equal to f inverse of B4, A5 is equal to f inverse of B4, and A6 equal to f inverse of B5, A7 is equal to f inverse of B5. Now for this B2 and B6 you are observing that there is no relation in the set A. So that time what we'll write, B2 is equal to f inverse of 5. So same method here also, B6 is equal to f inverse of pi. About inverse of an element, let's discuss in detail with this diagram as a table. I'll write as a table this diagram, whichever is there we discussed, you can understand clearly. Let's move on to that. Right, from this you can observe element of A corresponding element of B. So first element of A, what are those? A1, A2, A3, A4, A5, A6, A7. So write that A2, A3, A4, A5, A6, A7. So now you can check. So A1 means what is associated with B3. So A2 is associated with B1. A3 is associated with B4. A4 also associated with B4. A5 also associated with B4. A6 is associated with B5. A7 is also associated with B5 only. So write that B5. I hope so you are understanding what I am explaining. So first A1, A1B3, A2B1, A3B4, A4B4, A5B4, A6B5, A7B5. That only was written here. So after that our inverse form is what I said, F inverse of, so what I can write, F inverse of B3 is equal to A1. Same method, can you tell for this? F inverse of, so again F inverse of B1 is equal to A2. So now F inverse of B4 here, so that B4 is equal to A3. Same method can you tell for next? So F inverse of B4 is equal to A4. F inverse of B4 is equal to A5. Same method next. F inverse of B5 is equal to A6. F inverse of B5 is equal to A6. F inverse of B5 is equal to A7. So this is about inverse form or inverse of an element. So inverse of element B3 is A1, inverse of element B1 is equal to A2 under the form. So this is about how to find the inverse of an element. So F inverse of B3 A1, F inverse of B1 A2, so and so on. F inverse of B5 is equal to S1. But you just observe here carefully, B2 and B6 is not, no element is associated with capital A. So that what we can write here it is F inverse of B2 is equal to no element, that's what represent with pi. So F inverse of B6 is equal to pi. So what you understand here now? So if any element is associated with that, and we'll write in this form, and if no element is associated with this, no element is associated with the capital A, then we can write it as F inverse of, so here B2 is not associated with any element of A. The same method B6 also not associated with any element of A, so that F inverse of B2 is equal to pi, F inverse of B6 is, if not associated with any element, then we can write it as pi. So this is about inverse of an element. Let's move on to the next topic. Let's move on to the next topic, that is inverse of a function. So this is complete definition. I was giving for you complete definition. The reason behind that, so you just need to write and understand the each and every definition clearly. So let's move on to inverse of a function. Let f maps a to b be a bijection, then a function f maps a to b to a, which associate to each element of y belongs to capital B to a unique element x belongs to a, such that f of x is equal to y is called the inverse of. So here you are observing that clearly here it is mentioned f maps a to b is a bijection. Then only it is possible to get an inverse of a function. So what is bijection? So a function should be 1 to 1 and onto. F should be 1 to 1 and same manner F should be onto. Then it is called as a bijection. Then F inverse or inverse of a function is possible. Otherwise it is not at all possible. So that's what here we given here. Y belongs to B to a unique element x belongs to A, such that f of x equal to y is called as inverse of f. So now we can write f maps A to B, and f inverse means that is B to A. So now f x is equal to y. So now here f is multiplying with x and it goes to that side, it becomes as 1 upon f, that is nothing but f inverse. So f inverse of y is equal to x. So now in diagrammatic form also we are represented here. You just observe set A, set B, set A, capital B. Now you can observe here f is a function A to B, f inverse is a function B to A. Or we can say that f inverse maps to B to A, f maps to A to B. Here observe that unique element is there. So means unique relationship is there with y to the x. So that's the reason it becomes as a inverse of a function. So let we discuss in detail in the ordered pair form. Okay. Ordered pair form. If f is equal to x comma y, such that x belongs to A, y belongs to capital B. Then what is f inverse means? Just exchange, interchange. So y comma x such that x belongs to A, y belongs to B. So now one example we'll take so that you can understand. how to write this one. So if in the exam if they give an f is equal to a1 b2 c3 like this, how to write f inverse? So we can write directly f inverse is equal, interchange that elements and write 1 comma a. So you tell second 2 comma b, next one 3 comma c. So that is about your f inverse function. So let's move on to the next topic. Alright, now we are method to find inverse of any function. So whichever the function it is, this is a method how to find an inverse function. So now here you must remember this important point. If f maps a to b is 1 to 1 onto or bijective, then function f can be found by using these following steps. Means only if 1 to 1 onto, then only we have to apply these steps. So let me check now what is first step. One, put f of x is equal to y, where y belongs to b and x belongs to a. Then second step is what? Solve the equation f of x is equal to y and obtain x in the form of y. And third step, put x is equal to f inverse of this inverse function. So now here we just solve one example we'll take and we'll solve, then you can understand. Here in this example, f is a bijective, f maps R to R, f of x is equal to x cube plus 2, find f inverse. Now what is first step? Put f of x is equal to y. So let me write what is here. F of x is equal to x cube plus 2 is equal to y. And second, what they said, solve the equation f of x is equal to x cube plus 2 is equal to y. So now, so here observe, solve the equation f of x is equal to y and obtain x in the form of y. So what we need to do is these two just you can solve and get the answer. So it is like we can write it as f of x is equal to y one side, other side fy is equal to x cube plus 2. So after writing this, they said solve for x. A plus 2 comes to here, minus 2. So y minus 2 is equal to x cube. This process is called as what? Sending one side to other side, transposition. So now here x cube is there. It goes to that side, whole to the power of 1 upon 3. So you can write y minus 2 whole to the power of 1 upon 3 is equal to x. And this also here f is multiplying, go to that side, division. X is equal to 1 upon f into y. So then what we'll write here, 1 upon f is nothing but you already know that f inverse of y. So this is your third step. What they said, put x is equal to f inverse of y. How this f inverse of y came here, I was explained to you how clearly. And now, so they said f inverse of y is equal to x. So now f inverse of y is equal to x means what do you know? Y minus 2 whole power 1 upon 3. This is your f inverse function. If you want to write in terms of x, then what we need to do? F inverse y plus substitute x. F inverse of x is equal to x minus 2 whole to the power of 1 upon 3. So in this way we are going to find inverse of any function, whatever it is. If it is 1 to 1 and on to, then only we have to apply this step 1, step 2, step 3. Then you can find inverse of any function. So here note, you need to remember this note. What is that note? So if any function 1 to 1 on to, then only inverse of a function possible. So you can write as a note, if any function is 1 to 1 onto, then only f inverse is possible. So that is about your how to find inverse of any function. So this is the method. So we'll move on to the next topic. Next topic, domain and range of inverse function. Domain of f inverse is equal to range of f. Range of f inverse is equal to domain of f. What is meaning of this, sir? So let me understand what is the domain and range of inverse function. Let me take one example. Capital A is equal to 1, 2, 3, 4. Capital B is equal to A, B, C, D. So that relation was given. And now in this, what is your f? F is nothing but 1B. next 2a, next 3c, next 4d. So I'll write separately domain and range so that you can understand. So now first I'll write F domain and range. So now what is F domain? Which is given as input, that means first element 1 2 3 4. So write 1 2 3 4. Now F range, whichever the second element, that B A C D. So write B A C D, or you can write A B C D also. So this is about domain and range of function F. Now F inverse. So here clearly you are observing that it is 1 to 1 and on 2. So what is F inverse? B comma 1 according to our definition, y comma x belongs to A comma y belongs to B, which is we discussed. So A comma 2, next we can write C comma 3, next we can write D comma 4. So now tell to me what is now F inverse domain. So here I'll write F inverse domain, all the first elements B, A, C, D, B comma, A comma, C comma, D. Next F inverse range, whichever the second element 1 2 3 4. Now you just observe domain of F inverse is equal to range of F. So here domain of F is nothing but domain of F inverse. So domain of F inverse B A C D, range of F. See, check range of F B A C D. So it is clear that F range is equal to F inverse domain, or F inverse domain is equal to F range of F. Same method now. Another also you can check range of F inverse. Range of F inverse is nothing but 1 2 3 4 is nothing but domain of F. Domain of F, what is the 1 2 3 4? So in this way you all are clearly understood that domain of F inverse is equal to range of F. Range of F inverse is equal to domain of. Some important properties of inverse function. You just remember when you are solving your examples or exercise problems, it is very important. One, inverse of a bijection is unique. Second one, if F maps A to B is a bijection, F inverse B to E is inverse of F, then F circle F inverse is equal to IB and F inverse circle F is equal to IA, where IA and IB are the identity functions on set A. If A is there, identity set on A, B is there, then we can write identity set on B. So now that is about your second property. And third property, the inverse of a bijection is also a bijection always. And now next, last and final, if F and G are to this is very important property also. You just remember, if F and G are two bijections such that G circle F is defined, then show that the inverse of G circle F, G circle F is defined, then inverse of G circle F existed or not, we need to check. Once if it is existed, then G circle F whole inverse is equal to F inverse circle G inverse. So these are the important properties of inverse of a function. So just remember it, and if you want write down this all and remember it. Example problems and exercise problems, then we can use these properties. Let's move on to the part number 2 next. So before going to the part number 2, we just remember all the definitions which I was given in this part number 1. These are very important before going to that examples and exercise problems.